Hello, everyone. Thanks for coming. Now, let me introduce myself first. My name is Zhou Yibo, and I work at Business. I'm a software engineer focused on cloud, KVM, and container. Now, I'm going to talk about the aggressive PV IPI and the Passthrough timer technologies which have been applied in our private cloud environment. Now, let me begin my topic. This is the agenda of the topic. Firstly, I will talk about the background. What problems are in our scenario? And then the solutions about these problems will be offered. And lastly, we'll talk about the future work for our solution. The background. Firstly, let's talk about the timer axis. The timer axis, which contributes to the overhead of virtualization significantly. Currently, the timer of the VM is emulated by VM. Therefore, arming, disarming, firing timers will cause VMExits. In our product environment, most of timer exits are caused by reprogramming timer, as shown on the graph. There are many reprogramming timer operations before timer firing. Okay, let's see the problems to IPI exits. IPI exits are also a big portion of overhead in our scenario, since large VMs are widely used. The left table is the typical skills of VMs used in business. The statistics of the IPI VMExits is also present on graph down right. You can see the IPI VMX of our scenario can cause up to 550,000 VMExits every 5 minutes. Also, features of PV IPI are implemented in upstream, but they don't resolve our issues very well. Okay, let's see solutions. As I have talked about issues encountered in our scenario, then let's talk about how we correct these problems. To eliminate the overhead caused by timer exits, exit next timer need to be developed. There are existing solutions developed by Tencent and Alibaba Cloud, but they don't meet our demands. Exit next timer proposed by me at the Tencent Cloud requires housekeeping CPUs and inject expired timer interrupt through post interrupt. Another design from Zhang Alibaba Cloud introduced modifications on guest cloud and the reserve of a dedicated CPU for handling timer interrupts. Okay, next see our solutions to overcome the problems in existing solutions. We proposed a new exit next timer. We called it a Passthrough timer. In Passthrough timer, the VM can use a physical epic timer directly. So the host timer will be offloaded to the preemption timer when VM entry. When external interrupt exit happened, if the external interrupt vector is local timer vector, we should inject the timer interrupt for VM. In order to VM use physical epic timer, the epic timer of the VM should work in TSC deadline mode. And then in VM, the intercept of TSC deadline MSR should be disabled. Lastly, we must adjust the host TSC value when VM entry. For VM use the physical TSC successfully because the TSC value of the VM is less than host TSC value of with. In my Passthrough timer environment, the VM uses the physical timer directly. So if we wanted to make a host timer work normally, we must do some things. On VM entry, we must get the latest timer, the host which will be expired, and offload it to preemption timer. When on VMExits and VCPU pre-block, we restore the host timer to physical timer again, and then the VM timer to soft timer, which is emulated by VM. Pre-immersion timer is paired, which indicates that the host clock event will be called. This slider shows the difference between normal VM epic timer and the VM Passthrough timer. You can see in our design, VM can program the epic timer without trigger VM exit anymore. Okay, in this slider, the performance test result is presented. You can see throughput of sets and gets operations of VMExits increased 35.5% after adopting our Passthrough timer. Another test, cyclic test, which indicates schedule latency, also shows improvement after use our Passthrough timer. Okay, let's talk about the IPI VMExits. A possible implementation of Exitless IPI has been developed by me from Tencent Cloud. This implementation marks all these CPUs in a bitmap, and then send the IPIs to all these CPUs together by one hypercore. And then the VM scans the bitmap and get the list CPUs from the bitmap, and then send the IPI to the CPU in bitmap one by one. In other words, this implementation merge multi-IPI VMX into one VMExit. Okay, in our solutions, we adopt a low exit PV IPI. We realized this low exit PV IPI by pass-through PI discrete to guest and do not intercept SAR MSR. In VM Startup, we offer dedicated PV SAR for guests to send a special interrupt, such as SMI, NMI. And in guest, it can send the IPI directly via post interrupt and without VMExits. Now this diagram shows how low exit PV IPI works. For example, in guest, the vCPU 0 send the IPI to vCPU 1. Firstly, we must get the PID script of vCPU 1, and then we cite PV IPI vector in post interrupt request bitmap of PID script of vCPU 1. Then we set outstanding notification in PID script. The outstanding notification will tell the hardware there is a pending LQ to solve. And then we get a notification vector from the PID script. And the notification vector is always a post-interrupt vector. But if the vCPU in hot state, the notification vector is a post-interrupt wake up vector. And then we prepare SAR. And lastly, we write SAR. So the IPI is triggered successfully and without VMExits. Okay, let's see the test interrupt. Sorry. Let's see the test result of the low exit PV IPI. After adopting low exit PV IPI, the cost of a single IPI operation in VM decreased from 11,486 to 412 cycles. Single PV IPI can perform on the level of bare metal. From the perspective of the application level, low exit PV IPI can also improve the throughput significantly. In our scenario, reliable sets and gets operations per second of VMExits raised 14.8% after introducing low exit PV IPI. Okay, let's see future work. Also, there are many benefits by introducing pass-through timer and low exit PV IPI, but there are some potential problems need to be addressed. In terms of low exit PV IPI, the guest should be trustable because the guest can access the SAR, MSR, and the PID script. This will allow guests send the PV. This will allow guests send the IPS to an arbitrary physical CPU. In our private closed scenario, we can accept a trade-off between performance and security, because the guest is generally considered to be credible. But the work of making low exit PV IPI more secure still needs to be done. When security is concerned, the security hardening of PV IPI could be implemented. For example, via EPTP switch feature of VMthink. For pass-through timer, guests couldn't affect any other VMs. So the security of pass-through is not the major concern. In future, works of supporting new migration and dynamic switch may be valuable. Okay, this is all contents of my topic. If you have any questions, you can connect me via the email. Okay, thanks.